All right. So if you've ever tried to get an AI to do something specific, repeatable for your job, you know the feeling, right? It's this special kind of frustration. It doesn't feel like you're using a tool. It feels more like you're in a negotiation that never ends. Well, in this explainer, we're going to dig into exactly why that is, and even better, how you can actually start winning that fight.
This just says it all, doesn't it? It perfectly captures that feeling that you're constantly trying to, well, break the model. Like you're forcing it into a box it was never designed for. And you're not trying to cause problems, you're just trying to get consistent results.
So let's get into it. Why is this feeling so universal? Why does it seem like the second we ask an AI to do more than just have a conversation, we're suddenly in a battle with it?
Yeah, that's really the heart of the matter. And look, that friction, it's not your fault. It's what happens when we take a tool that was built for creative, open-ended conversation, an LLM, and then we try to jam it into a business process that absolutely demands predictability and structure. Their basic purposes are just pulling in opposite directions.
Okay, that makes sense. It sounds like a real fundamental clash. So can you break that down for us a little more? What exactly are these two different kinds of systems?
For sure. So on one side, you've got your traditional software. That stuff is deterministic. It's built for consistency, for control. You give it the same input, you get the exact same output every single time. It's just following a strict rulebook. That's the world of business. But then on the other side, you've got LLMs, and they're probabilistic. They thrive on context and ambiguity. They aren't following a strict rulebook. They're estimating the most likely answer based on trillions of patterns. And that's where all that creative variability comes from.
And you can see here why this is so much more than just a tech headache. I mean, think about it. If you're in finance or healthcare, you have to have an audit trail. You need to prove why a system made a certain decision. And for any company, customer trust is built on getting the same reliable experience over and over. When a key part of your system is unpredictable, the whole thing starts to feel unstable.
Okay, so if these models are naturally unpredictable, how are engineers supposed to build anything reliable on top of them? How do you even begin to bridge that chasm between the probabilistic model and the deterministic world of business?
It all comes down to building guardrails. The very first step, as you see here, is enforcing structured outputs. So instead of letting the model just talk, you force it to respond in a very specific format, like JSON. That leads to step 2, function calling. This is key. The model doesn't do anything itself. It just creates the perfectly formatted request to call an outside tool. And that brings us to the most important part, step 3, tool execution. A totally separate deterministic program takes that request and carries out the action. It's a brilliant way to separate the AI's fuzzy reasoning from the cold, hard, irreversible action.
Right, so those are techniques for controlling the output at that one specific moment. But is that really enough? When you're talking about really complex or high-stakes operations, it still feels like a lot could go wrong.
You are absolutely right. And that's why we have to think bigger, beyond just the prompt itself. This quote just nails it. You can't just hope for the best. Pleading with your AI in a prompt, hey, please don't delete everything, well, that is not a security strategy.
So the real solution has to be architectural. This is where you get this idea of a logic firewall, or as we see here, a constraint engine. It's a completely separate deterministic system that acts as a gatekeeper. The AI can come up with a plan, sure, but that plan has to get through this non-AI firewall, which has hard-coded rules, before anything is allowed to happen in the real world.
And you can build on that idea for even more complex stuff. Architects are now using what are called transactional patterns, like Saga LLM. The basic idea is you break down a huge task into tiny, manageable steps. Each little step gets checked and verified, and if any single step fails, the whole system knows how to roll back or undo the previous steps to keep everything consistent. It's all about building a reliable system around the AI, not just trusting the AI itself.
That all sounds really smart in theory, these firewalls, these transactional systems. But it also sounds like a lot of work. How much do we really need it? How good are today's top AI agents at just following a simple set of rules on their own?
That is the million-dollar question. And luckily, we've got some hard data on this. Researchers have created benchmarks specifically to test this. One of the best ones is called SOP Bench. Its entire job is to see how well AI agents can follow standard operating procedures. The exact kind of strict step-by-step rules that run pretty much every business out there.
Now, we're not talking about abstract puzzles here. SOP Bench runs these agents through realistic scenarios in banking, e-commerce,
places where the rules are everything. For example, a banking task might require the agent to verify a user's ID and then check their balance before it's allowed to approve a loan. The order matters. The steps are not optional.
So, how do they do? The results are, well, they're pretty sobering. This chart shows that even the absolute best models we have, GPT-4o, Claude 3.5, they only follow the rules correctly somewhere between 30 and 50% of the time. Let that sink in. They are failing to follow strict procedures more often than they succeed. This isn't a small quirk. It's a massive gap that proves why all those external guardrails we talked about are not just nice to have, they're completely non-negotiable.
Wow, okay, that really changes things. So let's circle all the way back to that initial feeling, that feeling of fighting the AI. What's the right way to think about this? What's the real takeaway? This right here is the big mindset shift. You are not the problem. You're not trying to break the model. What you're actually doing is trying to reduce its freedom. See, LLMs are built to be creative, to be helpful, to fill in the gaps. For a business process, you need to take that wide-open creative freedom and constrain it, tame it, to get the reliability you need.
So here's the bottom line. You're not a frustrated user wrestling with a stubborn tool. You're a system builder. Every rule you write, every schema you define, every validation layer you put in place, you are literally constructing an operating environment. You're building a system that can take this incredibly powerful probabilistic mind and turn it into a reliable, predictable component. You're not fighting it, you're engineering control.
And that really brings us to the final question for everyone. Because as we put these powerful AI systems at the very core of how we work, the big challenge isn't just about using them anymore. It's about designing the worlds they live in. So, as you go back to your own work, the real question is this: what boundaries will you build?